Alright, let's solve this as quick as we can. So, yeah, you know how I solved the integral of e to the x sine squared x dx? Now I'm going to solve e to the x cosine squared x dx. I solved it pretty much straight away, but I've been pretty busy. It is possible. But then I was super curious. I'm like, what about tangent? That would be so much cooler. Unfortunately, it's not possible, so I can't explain how to show that. Let's do it. So, integral of e to the x cosine squared x dx. So, I'm going to rewrite the integral, and remember the first step was to use a trigonometric identity, the reduction formula, so to speak. It's not a reduction formula, as I ranted in the last video. So it's 1/2 1 plus cosine of 2x if you have a cosine squared x. Now, let's rewrite this integral. So it's 1/2 times the integral of e to the x 1 plus cosine of 2x dx. Now let's choose our u. Our u is going to be 1 plus cosine of 2x du. Man, I sound like I do not enjoy what I'm doing. But I love this integral. I had so much fun solving it for the first time. And you know how funny it is that I'm able to just talk and I'm not even really this is so automatic to me. Unfortunately, when you first learn integration by parts, you really need to have a good think about what you choose for your u and dv. I wish I was able to explain it a little better, you know, as to why I've chosen what I've chosen, but I've just done enough problems to know. There is a process behind it, and there is an acronym that you can refer to, but let's keep solving the integral. Oh, I'm going on a tangent. Tangent, alright. That was sad. Math jokes, what up? Alright, so now let's rewrite the integral. So the 1/2 is factored out front, so now we have uv minus the integral of v to u. So 1 plus cosine of 2x e to the x minus, this 2 comes out the front, and that was a minus sign here, so it's actually plus 2 times the integral of e to the x sine of 2x dx. Alright, well, that's our new integral. And you remember from the last video exactly what we had to do. We had to do integration by parts again. So we let u equal sine of 2x. And du is equal to 2 cosine of 2x dx. dv is equal to e to the x. Man, how was your day? I do this every single time. And it's not even actually that funny. It's actually kind of, you know, depressing. So I know that this is going to be a pretty long expression, so I'm going to give myself some room. So I have the original expression that I have from before because I integrated this. And then I have plus 2. This 2 is factored out now. So now 2 times the expanded form of this integral, which is just uv minus the integral v to u. This integral is now uv minus the integral v to u. So that's why I've got a 2 expanded out here. So sine of 2x u v e to the x minus the integral, well, it's actually minus 2 times the integral because it's 2 v du, but it's e to the x, and du is 2 cosine 2x dx, and that's why that 2 is at the front. Cosine of 2x dx, and that's the entire function. Now, you remember from the last video, if you didn't watch it, so what we've got to do is when you're doing integration problems, you almost get lost in the problem so much because you're doing so many different things at once that your mind can only really focus on one thing, especially when you're new to them for the first time. But this was the original integral we were trying to solve. So what we're doing now is equal to all of this, but I'm going to expand it all, this 1/2 to every term, so it's going to be 1 plus cosine of 2x e to the x over 2, and then that's 2 sine of 2x, which is actually being multiplied by 1/2, so it's plus sine of 2x e to the x. And this is 2 times negative 2 is negative 4 divided by 2, that's negative 2, minus 2 times the integral of e to the x cosine 2x dx. And now I'm going to add this to both sides. So now I'm going to rewrite this as the integral of e to the x cosine squared x dx plus 2 times the integral of e to the x cosine of 2x dx. Man, I actually did a video run before this. It got to about 8 minutes. But I realized that my voice was really monotone in the entire video, and I'm like, oh, I'm doing this again. I'm going to be a little more interesting. Anyway, this is equal to dot dot dot. So now what? Well, what we've got to do is we're going to write down the identities for cosine of 2x, and that's just equal to cosine squared x minus, sorry about this, sine squared x. That's off the page. That's actually sad, sorry about that. Or it's equal to 2 cosine squared x minus 1, or it's equal to 1 minus 2 sine squared x. It's this one this time, because we're trying to equate a cosine squared x with the original function. So now, when we rewrite the integral, we still have our e dx cosine squared x dx, but now we have plus 2 times the integral of e dx, and it's not cosine of 2x anymore, it's 2 cosine squared x minus 1 dx is equal to dot dot dot. And now we rewrite our integral again, so e dx cosine squared x dx is... Now, let's expand it out. Well, this 2 is getting expanded to each term, right? So this 2 will go to this one. Obviously, e to the x does as well. But it also goes to this negative 1 here. So we're going to have 4 e to the x cosine squared x, but we already have 1 here. So we're going to have 5 of this integral e to the x cosine squared x dx, just like we did in the last example. But this time, we're going to have minus 2 times the integral of e to the x dx is equal to dot dot dot. Now we have 5 times the integral of e dx cosine squared x dx. I'm going to write down the right hand side now. So we had 1 plus cosine of 2x e to the x. Now if you remember from my last video, I know I keep referring to my last video. It's like, well, what if you didn't watch it? Well, I'm sorry. I'm going to create a lot. I was actually pointing to the screen. I'm sorry. So we're going to actually find the lowest common denominator. So I'm going to multiply this up and top by 2. Up and top, they mean the same thing. This is how you know I'm like out of it right now. So I'm going to have a big division symbol here called 2. Because at the end of the day, everything's going to have a common denominator of 2. So I'm going to have plus 2 sine of 2x e to the x. And when I add this negative 2 e to the x to both sides, well, that's plus 2 e to the x. But if I'm going to have a common denominator of 2, this is plus 4 e to the x. And I'll forget about the plus c for now, but I'm about to write my final answer just as I'm about to get off the page, which is cool. So I'm going to divide this by 5, and it's now the integral of e dx cosine squared x dx. You'll see it's so similar to the original the sine one, but this is the final answer. So I'm gonna do a little line there so it's not interfering with the problem. Well, I've got 1 plus cosine 2x e dx, and I have plus 2 sine of 2x e dx, I have plus 4 e dx, all over 2, actually 10 plus c, because I'm divided by 5 if you recall. So that's the final answer. So yeah, so 1 plus cosine 2x e dx plus 2 sine of 2x e dx plus 4 e to the x all over 10 plus c. And that is so similar to the sine example. Anyway, that's the end of the problem. Sorry that's messy, but yeah, no, it took up an entire page, man. So that was the original problem. Thanks for watching. And it is possible, and I am going to probably try e to the x sine cubed x dx next time. That looks really interesting, and I know it's possible. So that'll probably take me a lot more than just one video to solve. Anyway, take care.